Entrance and beyond. This is day 9 of my DSA series. Today I will be discussing question number 2410, which is maximum matching of players with trainers. So let's dive right into the question. So the question states you are given a zero indexed integer array players, where players of I represents the ability of the ith player. You are also given a zero indexed integer array trainers, where trainers of j represents the training capacity of the jth trainer. The ith player can match with the jth trainer if the player's ability is less than or equal to the trainer's training capacity. Additionally, the ith player can be matched with at most one trainer, and the jth trainer can be matched with at most one player. Return the maximum number of matchings between players and trainers that satisfy these conditions. So let's look at the test cases. The first test case has players is equal to 4, 7, 9. Trainers is equal to 8, 2, 5, 8. The output is 2. So one way we can form two matchings is as follows. Player 0 can be matched with trainer 0 since 4 is less than or equal to 8. Player 1 can be matched with trainer 3 since 7 is less than or equal to 8. It can be proven that 2 is the maximum number of matchings that can be formed. And the second example here is equal to 1, 1, trainer is equal to 10, 1. The trainer can be matched with any other 3 players. Each player can only be matched with one trainer, so maximum answer is 1. So let's copy the test case and then understand this question in a bit more depth. So I'm going to copy this entire thing for you guys. Okay, let's copy it. Now we have it over here. This is the entire question that we are going to dive into. So I'll make things clear. We're basically given two arrays. So one array is our array players, and players of I basically represents the ability of the ith player, and then we are given another array trainers, where trainers of j represents the training capacity of the jth player. The ith player can match with the jth trainer only if the player's ability is less than or equal to the trainer's capacity. Additionally, the ith player can be matched with at most one trainer, and one trainer can be matched with at most one player. Well, that is pretty much all that we have to do. So I'm going to copy a test case and I am going to dive into it. So this is pretty much it. This is our test case. We are given an array players and our second array is array trainers. I'll move that down just so that things are a bit more clear. Now this is basically our array players. This is our array trainers. So what could be the intuition in maximizing the number of mappings that we could do? Like, what if we directly try to match players with trainers? So what we would do in that case is we would just take a pointer. Let's say this is our pointer. So we're gonna take a pointer basically. So we're gonna start off with this player number 4. That is the player that we're focusing on. And what we're going to do is we're going to search in trainers till we find a value that's greater than 4. So we can see that A is greater than 4. So we can say that one matching is done. Then we go to 7. For 7, we see that 8 has already been used. This trainer has been used, so we could basically convert this to 0. So for 7, we basically start off with this 8 has already been used. That is fine. Has 2 been used, 2 is not greater, 5 is not greater, 8 is greater in fact, so we can convert this to 0, and we can say our count becomes 2, and then we go for 9, and in 9 we see that this is 0, this won't match, this won't match, this won't match, this won't match, so we can say our final output is 2. So that is one of the basic approaches, but you can understand that the time complexity would be the size of this multiplied by the size of this, because how many times we loop through this? For each element over here, we went through this entire length. So basically, suppose the size is 3, this size is 4, so each of the 3 elements, we went through all four elements. This basically gives a time of 12, which can be seen as kind of being n square in some sort of way, n into m, to be more concise. So this was the brute force approach, and you probably understood it. But do you think there can be a optimized approach? So we've understood the brute force approach. That is perfectly fine. We've understood how the brute force approach would work. This was basically the brute force approach. Now let's try to find out an optimized approach. There must be some sort of optimized approach, correct? So let's copy this again. Let's copy it. Let's copy it and paste it down over here. This is what we have. Now, how can we do it? Now in this question, we must employ a greedy sort of approach. And how would we employ the greedy sort of approach? We basically want a mapping where the difference between players I and trainers J is minimized, just so that we're not using a really big value, a very good trainer, for a very weak or very you can say very new player. That is what I'm trying to say. So like in this case, wouldn't it be better if we matched 4 to 5? Like logically speaking, that does make sense, right? Mapping 4 to 5 would be way better, because we don't want to waste our resources. If we map suppose 4 with 8, and suppose we had some sort of value instead of suppose we didn't have this, we just had this 7, right? And suppose we didn't have this other 8. So in that case, if we went by this approach, like if you directly went by this approach, we might actually get the wrong answer, because you can see for 4 we can say that this is the first guy that matches, so we're just gonna map him to it. But then when you come to 7, you can't use this trainer, you can't use this trainer, you can't use this trainer. So the answer that would come would be 1. But is that the correct answer? Say definitely not. That won't be the correct answer. 1 won't be the correct answer. Suppose we don't have this element, right? Now what I'm trying to say is, suppose we don't have this 8. We just had something like 8, 2, 5, and 4, 7, 9. So you know what the answer would be? The answer would be 2, because we would take this 4, we would map it with this 5 over here, and we would take this 7, and now we can see that we can map it with this trainer over here. So the output actually has to be 2, but what we ended up returning was something way different. We ended up returning an output of 1. And why was that the case? That was the case because we are basically underutilizing the resources for a player that isn't that experienced. We're giving him the trainer that has a huge capacity. So we're wasting that trainer, in short. That is what's happening. So that is how our second approach comes into play. So what we're going to do in the second approach is, we are going to sort both players and trainers in ascending order. So what would that look like? This is what we have, correct? I'll show them side by side. What I'm saying is, let's sort both of them. So after sorting, what would we get? What do we get after sorting? After sorting, what do we get? Let's say we sort both of them, and we will basically have a new input now. So after sorting, over here we can get 4, 7, 9. This is already sorted, and over here we're gonna get 2, 5, 8, 8. Now we can just compare adjacent elements, and if a match is found, we increment count by 1. If a match is not found with adjacent elements, we go to the next element. So what I'm trying to say is, it would be something like this. We start off with 4. Does 4 and 2 match? Yes, it does count, becomes 1. Then we start off with 7. 7 and 5 doesn't match. We move J ahead. We basically have 2 pointers. One pointer that goes over here, so we move this ahead on the first array, and then we move J ahead. Now match is found. Now we can move this I ahead, and then we can have this J, and we are done. And what this guarantees is, we don't have to search through all the elements. We only have to search through some of the elements. Like in this case, we know that if 5 doesn't satisfy 7, it won't satisfy the next element over here, so we can definitely move ahead. So that wouldn't really make a difference. So hopefully this did make sense to you. So it's pretty simple. We're just going to use the sort function, and end up taking n log n time, better than n into m at least. So we're just going to sort both of them. Sort players dot begin, that would basically be our iterator, in short, pointing to the first element, and players dot end, that points to the one element after the last element. And then we do the same thing with trainers. We sort it, so trainers dot begin dot trainers dot end, sort both of it. Then we have int I is equal to 0, j is equal to 0. So we can have a simple condition while I is less than players dot size, and j is less than trainers dot size. What do we have to do? What do we have to do? In that case, we're gonna check if we need another variable count just to store the answer. So we can say players of I, if it's less than trainers of j, less than or equal to, we can do count plus plus. and we increment. In this case, we increment both I and j, and then in the else condition, we could just increment j, else j plus plus. We return our count, and this should give us the correct answer. And this approach basically takes and big option, we submit, we get the correct answer. So thank you so much for tuning in. Hopefully things are making sense, and do mention in the comments if you are still facing any doubts, or maybe if I should explain it in some other language. Feel free to do that. So thank you so much.